We're looking at the number of people in a household in the US as a function of the years since 2005. So our output is people, and our input is in years since 2005. In question A, at what rate are households growing each year? Well, because our rate of change, even though we're not finding it manually here, is a value of change in output over change in input. So change in output would be people, change in input would be years. So that means that on average, households are growing by 0.0029 people per year. That may not seem like a lot, and it certainly isn't. That would also be equivalent to saying this would be 2.9 people over 1,000 years. So that may be more of a big deal, assuming we're around that long. We'd see about 2.9 more people in a family in 1,000 years. But that's, of course, too far to predict in advance. How many people were in a family in the initial year? Well, in year 0, the number of people as a function of year 0 would be 0.0029 times 0 plus 2.5629. So there were about 2.56 people. So about, on average, 2.5 people. Of course, you can't have half a person. Some people have 2, some people have 3, but it averages out to this number. Find the horizontal intercept. What is its real-world meaning? So this is where our output is 0, 0.0029y plus 2.5629. So we subtract 2.5629, get negative 2.5629 equals 0.0029y. And now we'll come over to our calculator and type this in. We'll do negative 2.5629 divided by 0.0029, and we get negative 883, which we can already tell is kind of a strange value. So it's about negative 884. Okay, so what does this mean? Well, this was where we put our output, we let our output be 0. Well, our output is the number of households. So does it make sense to say that the number of households, number of people in a household was 0, negative 884 years before 2005? Probably not. Probably doesn't make too much sense, but graphically, we're just saying that the horizontal intercept is somewhere over here, and our graph looks something like this. In what year is it expected that there will be 4 people per household? Well, this will be when we get 4 equals 0.0029y plus 2.5629. And we would subtract 4 minus 2.5629 equals 0.0029y. And so we get 4 minus 2.5629. And we're going to divide that by negative 0.0029. And we get, oops, let's see, what did I do incorrectly here? Oops, I guess I didn't need the parenthesis. And we get y is about negative 496. Again, that doesn't make sense. The number of people, well, we shouldn't have the negative sign here. It should actually be a positive. This was a decimal place. So does that make sense to say that in 496 years there will be 4 people per household? Probably not, just because that's so far out into the future. That might be, who knows what will be taking place back at that time. The other one would be found the same way, except we do 5 minus 2.5629 equals 0.0029y. So this would be when will they have 5 people? 5 minus 2.5629. Divide that by 0.0029, and we get y is about 840 years. So in 840 years, we could expect that people will have about 5 people per family. Again, not very sensible to say that. Why is it not okay to continue making projections with the given equation? Well, as we already see, going too many years out, we have no idea what's going to happen. So going out more than just a couple of years beyond 2005 probably doesn't make a whole lot of sense.